Thanks, everyone, for joining us for another episode of Beauty and the BS. Today, we have Dr. Brian Kennedy, who is an internationally recognized researcher in the field of biology and aging, and is really a visionary committed to translating research discoveries into new ways of detecting, delaying, preventing, and treating human aging and associated diseases. He's a distinguished professor of biochemistry and physiology at the National University of Singapore. He serves as a director for the Center for Healthy Longevity at the National University Health System, where aging research seeks to demonstrate that longevity interventions can be successfully employed in humans to extend health span, which is the disease-free and highly functional period of life. Dr. Kennedy was previously the president and CEO of the Buck Institute for Research. He is the editor-in-chief, co-editor-in-chief of the journal Aging Cell. And one of the goals of Dr. Kennedy's research is to determine whether certain pathways can be regulated to treat the diseases of aging. Specifically, Dr. Kennedy's lab focuses on cardiovascular disease and metabolic syndromes like type 2 diabetes. Dr. Kennedy, thank you so much for joining us today.
Oh, it's my pleasure to be here.
You are really one of the premier researchers in the field of aging, a field that is growing and changing, and one that I think is benefited because it's now looked at with greater interest, because funding has finally come into the arena for many people where it may not have been there before. But before we get into that, tell us a little bit about your background. How did you end up, well, I know you're in Singapore right now, which is far away from a boy from Kentucky.
I've been exiled.
Tell us about your background.
Yeah, no, happy to. When I went to do my PhD at MIT, I wanted to work in something just completely out there. And there was another graduate student who we decided to join forces and pick a topic that not many people work on. Aging was always appealing to me because I'm the only child in my whole family, or I was at the time. And so I was around all these aunts and uncles and grandparents and great-grandparents, and they were getting old in different ways. And I got to watch how that happened. And some people were very healthy and happy, and others were bitter. And so I was curious, how do you get to a point where you're having a contented, healthy old age? And so when the opportunity came up to work on aging at MIT, we decided to take it. So we worked in Lenny Guarenti's lab on yeast cells, of all things. The thinking was that if we could at least understand aging in a very simple single-celled organism, then we might be able to get some clues as to how aging happens in humans. And so that we found sirtuins that way, which has led to a whole field of research, and that got me hooked on doing aging. It didn't get Nick, my partner, hooked as much on doing aging research because he's now a priest, but
He found a different path.
Actually, he's a priest biologist. He has a small lab and studies aging still, in a way.
Kind of like Mendel, I guess, right? You can kind of into
exactly.
Well, that's interesting. So you ended up doing that, and you go from your research in MIT, and then you've kind of traveled in different parts of the country and now different parts of the world. How have you ended up, from there ultimately to Buck and then to Singapore?
Well, I got out of aging briefly and did some tumor suppressor work and cancer research at Harvard Medical School, and then took a job as a professor at the University of Washington in Seattle. And that's where I decided that I need to get back into aging research because that's my real excitement. And was there for 10 years. I switched to working on more complicated systems like mice, and then took the position as CEO of the Buck Institute for Research on Aging, which is the biggest nonprofit research institute on aging. And stayed there for about 7 years, but it felt like at that time that I wanted to get into human studies more, and also that the Buck really at the time didn't have a connection with a hospital or anything like that. So the opportunity to come to Singapore, where there's a fully functioning, state-of-the-art hospital, geriatricians, endocrinologists, and maybe most importantly, patients and participants for your clinical trials is really was the draw that brought me there. Singapore is really an ideal place to think about aging because it's one of the longest lived countries in the world, and it also has one of the lowest birth rates. So by 2030, there's only going to be 2 working people for every retired person. So that's a recipe for economic disaster if we don't keep those people healthy. And if Singapore gets one thing, they get economics. So they're really motivated to figure out how to extend health span. So I feel like we can use this island as a test bed for trying to really alter how we think about medicine.
It's a very unique place. It's a beautiful city and just seemingly well run for those of us who've only been there one or two times.
Yeah, it is, and it's I won't go into detail, but just to give you an example of how well run it is financially, that when everybody else went broke paying for COVID problems, Singapore used about 30% of its rainy day fund. I mean, what other government even has a rainy day fund?
Yeah. Very unique place. All right, so let's talk, I don't want to say semantics, but tell me about the term anti-aging. We're using this term anti-aging so much in this area, and I guess because it just seems to fit, but do you think that's the appropriate term? Is that the terminology you're happy with when you talk about what you do?
Well, I think I'd answer that on 2 levels. One, anti-aging implies that we can reverse aging and in a way, or stop it completely. And I don't think we're there yet. So I think it's possible to slow aging and extend health span. And it may be possible to stop or reverse aging in the future. But I think a lot of scientists feel like it implies a lot more than can be achieved, at least at the moment. So that's why there's some hesitancy over that term. I think it's fine. It is semantics, and we tend to get bogged down in semantics in this field. And so we talk about extending healthy longevity, but people have to really think what that is. Anti-aging, they get right away. So I guess I kind of use both terms back and forth. The one other issue is that I think the aging research field at the time, this was maybe 10 years ago, felt like anti-aging was a term that was used by the supplement industry to make a lot of claims that weren't backed by science. And so there was an attempt to sort of differentiate the hardcore research approach from some of the stuff you might find on the storage or supplement shop. So I think that's changing, though, and one of the things we're doing in my lab is to really start to test a lot of these supplements, because some of them are likely to have effects on aging that could be very beneficial, but there's just not enough science behind most of them.
Do you have a definition for aging itself?
Well, that's another semantic argument, because if you get enough scientists in the room, you spend a half an hour arguing with each other and end up with shit happens and then you die. It's like because aging is sort of everything and nothing. It's like if you want to give a grant funding on aging, then everybody calls their research aging. And if you want to say, what is aging, it gets drilled down to something very narrow. So I can tell you how I think about it, at least, if maybe not a good definition. And that gets into some points we'll talk about later, because there have been papers coming out with hallmarks of aging, like the 9 pathways that drive aging, or I wrote one on pillars of aging with 7 pathways, and Aubrey de Grey's talked about 7 things. And so I think those have been great frameworks for thinking about aging, but I think in some ways they miss the point. And the reason is that if you look at all the interventions that have an effect on longevity in animal models, or almost all of them at least, they impact all of the pillars and hallmarks. So it's not as if you're hitting one thing, at least not with the technology we have now, and fixing that and you're living longer. What's happening is that all of these, let's say, pillars are connected in a network. And basically, it's your body's mechanism to maintain homeostasis. So all your cells are talking to each other. They're monitoring the damage that's happening. They're compensating for that, and they're trying to keep you healthy. And the problem is that when you have enough damage, enough, things get changed, your lifestyle choices, all of these things affect these pathways, that the network begins to break down. And when that network breaks down, you lose equilibrium, and that's when you start getting these diseases we're so scared of. So I think most of the interventions that work so far are hitting nodes in that network, and they're preserving the integrity of the network to keep you healthy longer. And that ultimately, maybe we can fix all of these hallmarks or pillars, but right now the evidence is that the interventions are touching on all of them. They're not specifically targeting one.
Would for sake of our discussion, would accumulation of damage over time seemingly be a relatively broad definition for aging?
I think that's certainly part of the cause of aging. I don't know if it's the only thing. There's stochastic things that happen. There are epigenetic changes, and we're still trying to sort out the relative contribution of each of these things, senescent cells. But certainly damage accumulates over time to your DNA. It accumulates to lipids in your cells and proteins. And that causes all kinds of problems. And we know it's important because the cell has dozens of mechanisms to try to repair that damage. But the problem is that the repair over time doesn't keep up with the damage. And I'm convinced that's certainly a major contributor to aging. I don't know if it's the only thing that's driving aging.
There's the idea from a lot of people that I'm going to try to age gracefully, which I always look at as an oxymoron because, as we get older, aging is not a graceful process. I see it as the accumulation of, disease, cancer, and diabetes, and heart disease, and fragility. But people look at it as inevitable. And yet there are some in your field who will say, not necessarily so. What do you feel about the inevitability of aging? And I'm talking now aging and not chronological age.
Sure. So you're talking about biologic age, which is, just to catch everybody up, chronologic age is what your passport says, and biologic age is how fast you're really aging. And we can start to measure that now. We can talk about that later. I think that we don't know whether aging is inevitable or not. It certainly seems to be some species out there that don't age, and so over time evolution has figured out approaches for biologic species to avoid aging, apparently. So that, at least conceptually, there's no reason that can't be done. But on the other hand, I don't think we've been able to take any species that ages and make it not age at this point. Now, that we do have big impacts. We can extend the lifespan of simple organisms like C. elegans for 10 or 15 times. And even mice we can extend maybe 40, 50% now if we do the right interventions. So I'm confident that aging is malleable. And we know that it's malleable in humans already. So sustained exercise, healthy diet, managing your stress, sleep quality, all these things influence healthy longevity. So there are things people can do now that don't even involve pills, although there may be pills available now too. So slowing it down, I'm very confident of. Whether we can stop it completely, I would say that I think it's likely possible, but I'm not sure the technologies we're using right now are going to be the ones that get us to that point.
So do you look at death as like a technical problem that we can solve, or at least delay?
I just don't plan on dying, so I don't worry about it.
Let me know how you figure that out.
Well, even if you stop aging, you're still going to have death, right? Because there's some percentage chance you're going to get hit by a bus, or So I think that my view on it is that what would I give for 5 extra years of healthy life, or 10 extra years, or 20 extra years? And so if we can validate the kinds of approaches now that are likely to give us those kinds of things, that's already a huge victory. And it's also gives us more time to make bigger discoveries too. So I do kind of like Aubrey de Grey's concept of escape velocity, and I don't know if we'll get there or not, but I think to me the biology is fascinating, and we're making a lot of progress in the field now that it's getting funded a little bit better and there are more people in it. So, I mean, when I started in aging research, you could fit all the professors working on it in a big Starbucks, and now it's it takes a convention center to even get close to that. So that's a good sign. We've got people coming from all walks of science. We're setting up a meeting on the physics of aging, So it's I think it's really exciting times, and I think some of the interventions we're testing now are going to have impacts on healthspan already. And so I think you probably take pills now and do that, but I don't think anything is going to have huge effects yet.
So we'll get back to longevity escape philosophy, which I think which I think is very interesting, and how the more we learn, the closer and closer we get to extending our lifespan or our health span, and to the point where at some point the curve goes up exponentially, and we can live healthier a lot longer. But for now, while life expectancy is increased significantly over the last 100 years or so, we really haven't significantly increased lifespan. What are your thoughts on that? I mean, for life expectancy, an average taken over, considering child mortality, considering all other factors, but for those reasons, we've been able to improve quality of life and the life expectancy as an average statistic.
Yeah. Yeah.
But the numbers aren't really raising that high.
I think there's two ways to answer that. Two questions really inside of that. One is that life expectancy is going up, but healthy life expectancy is not going up as fast. And so we're keeping people alive longer, but we're keeping them sick longer. And I think that's a product of how we do medicine, which is we do sick care. We wait till people get sick, and then they have chronic diseases of aging, which we more or less can't cure, but we can keep you alive longer with them. And of course, when I get sick, I want to get treated. I'm not against sick care. But we're not balancing that with true health care. And I think what aging research is pushing is a concept of really intervening in people while they're still healthy and functional, and keeping them healthy and functional longer, in addition to trying to treat them after they get sick. And I think that's an important facet of medicine that has to happen. It sounds obvious, but it really is a revolution, because doctors are paid on procedures. They're specialized in certain kinds of diseases. And this is a more holistic, preventative approach that doesn't fit nicely into the current healthcare system. So it's a major challenge to sort of get everyone thinking on this way. I think your other question was about maximum lifespan, really, which is not going up, or if it is going up, it's gone up very slowly compared to median or average lifespan. And I think that's an open question. On the one hand, in animal models, we can influence maximum lifespan for sure. So that suggests it can happen in humans. On the other hand, we haven't had that much impact in humans. And I think mostly it's because we're not doing anything about aging over the last 200 or 300 years. What we're doing is improving water quality and childbirth mortality and antibiotics and food security. Those are things that keep people from dying early for reasons that are not related to aging. And so what we've done is made progress toward fixing a lot of the non-age related causes of mortality, and we've created the aging problem. So if we want to do something about maximum life expectancy, we really have to target aging directly, I believe. So I think it will be possible, but at the moment, it's not clear if any of the interventions are going to do that or not. It's also a hard question to address, because it's difficult to do a clinical study where we start everybody on a drug at 60 and see if any of them live past 120. So,
Yeah, time is tough with that. But you've been a huge proponent of the fact that we do practice sick care and not true health care. And I mean, the dollars spent, at least in the United States, prove that. I mean, what the percentage of dollars spent at the last few years of life compared to during our healthy period of time is an enormous difference. And you would think that we would look at healthcare a little bit differently, but we kind of stuck in that model of sick care.
Well, I think there's, first of all, doctors have saved my life twice. What they do is great, but I think we're stuck in this perverse incentive system, which is based on extremely high healthcare costs, what you can get insured, what you can't get insured, Medicare, and the fact that everything is paid on procedure. If you look at more capitation models where, like in Costa Rica, where a doctor is paid based on the number of patients they have, and rather than the number of procedures they run, their life expectancy is higher than the United States. I mean, that method also has potential ways to go bad, but I think that we need to rethink how we do medicine. And I'm not against anyone making money. I'm not anti-capitalist, but we have to. When you look at a situation where childbirth mortality in the United States is 35th in the world, life expectancy, the last number I saw was around 62nd in the world, and yet we're paying 19% of our GDP for healthcare, something's going wrong. We need to fix this in some way, and I don't think that the majority of Americans are getting well served right now in terms of keeping them healthy. Go ahead.
Is there a country that you feel right now is kind of leading the way in true health care rather than sick care?
Well, I don't know if anybody's doing it extremely well. Singapore is at least aware of the problem and trying to do things. Japan is really good at managing aging. They're not really doing a lot yet on trying to slow or reverse aging, but first of all, the culture is set up toward more health. So if you look at older people, if you go around the subway in Tokyo, you'll have plenty of time because you'll get lost and be there for hours. What you'll find is that, little 80-year-old women are walking up and down the subway carrying their groceries because they want fresh food. So every day they walk to the grocery, or they walk to the store, or they take the subway to the store and carry their groceries back. In Western society, we've engineered so much exercise out of our lifestyle. We drive everywhere. We buy 2 months of food at Costco or whatever. And I think that we don't get enough activity in our normal lifestyle. And I think Asian countries have done a better job of that. Also, just the diet is better in Asia, especially Japan. But there's also an attitude of trying to work with people as they get older and keep them functional. And it's mostly, like I said, managing aging. It's like not necessarily new drugs to stop the aging process, but they're very good at that. And so I would say that their healthy life expectancy is longer as well as their life expectancy. Some European countries are also better than the U.S. in terms of helping people stay active and engaged.
Even though you can see that in certain countries, and I think certain areas of the United States, you'll see that. I mean, every country has certain areas where you see it.
Sure.
But people are still aging. You talk about blue zones and these people who are, 100, but they still look 90. They still look old. And I think for us at an age where we kind of still are kind of not really excited about our own mortality, what we would like to be able to see though is a prolonged health period, not the prolongation of dying. And there's a saying that I'm sure you're familiar with, is that we want to die young a long, long time from now. And how do we compress our morbidity? How do we find a way to be 100 years old as if we are 40 or 50? And we talked about healthy diet and exercising. I know you're a runner, and decrease stress, which isn't always easy to find ways to avoid stress, and they may slightly extend your life quality. But do you see us moving forward with the research that you're doing or your colleagues are doing to compress the morbidity so that we can die young a long time from now?
That's certainly the goal. I mean, some people, like I had both grandmothers live to almost 100. My one grandmother's 101, and she was exceptionally healthy. I mean, she bowled a 238 game when she was 92. She quit driving when she was 95. I mean, she didn't look 40, but she definitely didn't look in her 90s either. And she didn't lose any weight. She was active. Eventually, her heart valves gave out, and in a year she was dead. I don't think that's a bad goal to try to achieve. So, before I talk about and before I answer your question, I would say that there are ways to do that. I mean, in most cases, these centenarians chose the right parents, and hopefully they chose the right grandkids too, because I'd like that as well. But it's genetic. But some people do achieve that. I think that's exactly what we're trying to do, and at least on a smaller level, we've developed or studied this molecule alpha ketoglutarate, which does that. In animals, it compresses morbidity, so it only extends the lifespan of the mice by about 10%, but it reduces their frailty by 50%. And there's a company, Ponce de Leon Health, that sponsored this, which I'm involved with, full disclosure. But they made a product that's alpha ketoglutarate plus vitamins called Rejuvent, and we've been doing clinical studies with that. So far, what it suggests is that it's really helping people that are not aging well. So for people that are around their biologic age is around their chronologic age or maybe higher than their chronologic age, we're seeing a really big reduction in biologic age of 7 to 10 years in people taking this product using biomarkers. So if those biomarkers are really reflecting aging, I think that's what that's doing. It's not doing a lot for people that are super healthy at the time, but people that are not aging well, it's bringing them back to that health. It may not extend lifespan that much, but I think it will extend health span. So we're hoping that compresses morbidity in humans as well. I think that on a broader perspective, though, the pathways that we're targeting so far, they're going to have modest effects on aging. And the idea of putting them together and getting something huge is maybe that'll happen, but we've been trying combinations of things in mice, and just as often they cancel each other out as that they're additive. And so we haven't learned the rules for how to combine different interventions yet. But there are things that are on the horizon that I think may have a much bigger impact. Regenerating cells or reprogramming cells is, I think, one of the more exciting areas where you can, one of the things that happens as you get older is your stem cells get exhausted. Almost all of your tissues have stem cells, and they replace the damaged cells in those tissues. It happens at different rates in different tissues. It's very fast in the skin, very slow in the brain, but it happens to some extent everywhere. But those regenerative potential of those cells declines as you get older. And if you look at something like rapamycin or even AKG, it seems to help restore the regenerative potential of those stem cells. So that's one way to do it. But another way might be to take some of the other cells and reprogram them back to stem cells and in the body, and then let them function to replace and restore your tissues. And that's one way to repair damage in theory. So I think that ultimately may have a much bigger impact, although at the moment, there's also worries about toxicity and cancer and other things. So it's not ready for prime time. But some of the ideas that are on the horizon like that may ultimately have a much bigger effect on health span and lifespan.
So, you hit on so many topics that I just wanted to talk to you about. I mean, what we can do now, and I think I want to talk about Rejuvent and some of the other geroprotective drugs and supplements that are out there. Because I think that's probably realistically what our audience can do right now. But some of the stuff that you're working on, ultimately can have, and I don't mean to be I don't want to be, overstate the issue, but it's almost revolutionary if you think about what it can do to the human condition 20 years from now, 50 years from now, what can happen. And so you talk about, the damage that accumulates, and well, we lose cells, right? And maybe we can replace those with stem cells. And we have the opposite problem of the division of too many cells with cancer. And then we have these, death-resistant cells that tend to be toxic everywhere. Your focus right now in the lab is where?
I really should be working on attention deficit disorder because that's what I have.
My questions are just way too long.
No, we work on a lot of different pathways, and we work in everything from yeast and worms up to mice and humans. So the idea is to create a whole pipeline to first better understand aging, then develop interventions, validate them in animals first, and then move them into human studies and then ultimately into the community. So on the academic side, we work for relatively cost-effective interventions that we can scale. I also partner with a lot of companies, and there we can do cost-ineffective interventions too. I think that I've really decided, rather than just target one thing. I mean, we worked a lot on the TOR pathway over the years in rapamycin, but rather than target just one thing, to this be agnostic as an academic lab and start to compare and contrast which interventions work better, and also which biomarkers work better to measure biologic aging in people, so that we can get a ultimate feel on the best interventions for humans, and even better, personalize them. I mean, I don't think any intervention is going to work in every person. Even exercise, in a sense, doesn't, right? Some form of exercise probably helps everybody, but if I tell everybody to go run marathons, that's not going to be good for some people, right? So we need to figure out how to personalize aging interventions, and we're starting to do that even in mice. We're setting up a mouse spa where we bring genetically heterogeneous mice in at a year of age and try to measure everything about their aging in that mouse and develop a personalized intervention program for that mouse, and then see if we can outcompete using that approach, giving all the mice rapamycin or something. And I think there are a lot of longevity clinics around the world now that people can go spend, somewhere between moderate to obscene amounts of money trying to live longer, and they all say personalized medicine. I work with some of them, and I like what they're doing, but I'm not sure we have enough knowledge to really personalize. So we're trying to take a step back and see if that's even feasible in a mouse.
Yeah, I think there's so much good technology, but I find that there are kind of charlatans or mercenary bastards out there that just want to make money off of it, and
shocking, isn't it?
In my field, it's stem cells. I mean, people just say everything's a stem cell, and it can do everything. And look, I think stem cells in the lab are just fantastic, and the potentials are great. But clinical applications and certainly usages in aesthetic medicine are a little bit a little vague at this point in time.
There are a lot of untested things, and that's partly because of the war on stem cells by the U.S. government. But that I've tried mesenchymal stem cells, as in IV, and it's reasonable that they might affect aging. But the problem is that there's just so little clinical studies to really say that this is validated or not validated with these endpoints. And I think that, again, I think stem cells are a very promising area. We're working with a couple companies on stem cells now, but we need to put hard science behind it to validate what works and what doesn't.
Yeah, I think it's so important, and obviously better than most, but I just hate for its credibility to be sullied by those who are trying to make a profit off of it right now.
Yeah, and you go to conferences and you see here's one person that before and they had some disease and we gave them stem cells and now that's not science, right? I don't know if that's whether that's true, or maybe it's true, maybe it's not. It's N equals 1. We need real studies in this field because I think there is a lot of promise there.
You mentioned earlier about measuring biological age. And I think that's kind of very fascinating. I think the audience would like to hear about it. I mean, how do you do it? And why would an individual do it at this point in time? And with that information, what can you do with it?
Well, I think the first thing is that just to remind everyone that aging is the biggest risk factor for everything you're afraid of. You're even more likely to get hit by a bus when you're older. But you're more likely to get Alzheimer's and cancer and diabetes, and I could go on and on. And aging is driving functional decline. I always read these essays. I saw one in the Washington Post recently about, I don't want to stop aging because I'm gained wisdom and experience and I think differently and I don't want to give that up. And, that's not aging. That's chronology that gave you that experience and wisdom. Imagine if you had that and you were young, what could you do? And because you're declining in function as you get older. You don't run as fast, you don't think as fast, and that's happening, even in your 30s and 40s and 50s. You don't see many 40-year-old football players, and so I think that if we can slow aging, it's going to prevent the diseases, but also maintain function, which is so important. We tend to undervalue that, and so one way, before 10 years ago, we could just say, all right, do what your mother told you, get some exercise, stop eating all the fried food, and blah blah blah. But we couldn't measure it. Biomarkers of aging were really almost a failure. I mean, there were some measures like walking speed and grip strength and how fast you get out of a chair, and that's okay for predicting mortality in people over 70. But we're trying to slow aging in middle-aged populations, not frail older populations necessarily. And we need ways to measure aging in that age range. And that's where most baby boomers are. They're concerned about aging right now. They're in their 50s and 60s and in younger generations. And so what happened is that people started looking at deep data like DNA methylation across the whole genome, transcriptomics, proteomics in a lot of people. And they used machine learning initially and other forms of AI now to develop predictors of biologic age based on these data. Steve Horvath was one of the first people to do this from UCLA at the time. And that really has changed a lot about how we think about aging. And now there are many different aging clocks out there based on DNA methylation or other things. We have one we're using based on facial structure. We just take a three-dimensional reconstruction of your face with a camera, and we can predict your biologic age. So there are a lot of things out there. None of them are fully validated yet, but some of them seem to estimate your age reasonably well, and they predict mortality, and some of them appear to be reversible by interventions, which are the kind of things that we want biomarkers to do. So one of the things we're doing in the lab is we don't just do one biomarker when we do a study, we do 10 of them. And so then we can compare the biomarkers to each other, because ultimately we want to know how they relate to each other, which interventions affect which biomarkers, and what are the physiologic outcomes of that. And so we need to look at multiple biomarkers. I think if people are interested right now, though, there's companies that they can go to and they can donate some saliva or maybe a little bit of blood, and the companies will try to assess their biologic age. I think it's important because you may have a feel for how well you're aging, but you may not know. I mean, there are surprises out there, and if you're 50 and you find out you're biologically 58, that's a call to action. Maybe you should think more about some of these supplements that are out there that may slow aging, or certainly just rethink your lifestyle. The problem with lifestyle modifications is people don't want to do it. They need motivation. And this is a motivating factor if you're not aging particularly well, I think. So I encourage people to find out about their biology, and that's one way you can do it. Another thing I like is these metabolic monitors, glucose monitors that go in your arm for 2 weeks, because there's a lot of personalization about how people respond to what they eat in terms of their glucose levels. Does your glucose go up when you drink white wine? Unfortunately, mine doesn't that much, so I'm happy about that. But there are other things that drive my glucose through the roof, and it's worth knowing how you respond to what you eat, because then you can modify a little bit your dietary habits. Things like monitors like Oura Rings and Fitbits and stuff like that are also very helpful. They're giving you the feedback you need to start to change your lifestyle.
So I think most of us are hoping that we are around long enough so that the research that you and other colleagues are doing can really, substantially extend our health span, and as a byproduct, our lifespan. But until then, we need to think about what's out there. And there are a lot of your colleagues who are more open than others about sharing their thoughts of geroprotective drugs. Dr. Sinclair has, while not recommending it to others, has shared what he recommends. Yeah. There are others that maybe are a little bit more pessimistic about what those products. So I wanted to go through some of those products with you and ask your thoughts on them, as well as lifestyle changes. So one of the things that you just mentioned is, kind of lifestyle changes. And I got to tell you that I've fallen into the trap of listening to all these people and trying with them without a whole lot of data behind it, but just kind of, it sounds like a good idea. So one of the things that I started doing over the last 2 years was intermittent fasting, kind of simulating kind of the starvation. Tell me, or fasting. Tell me what your thoughts are on that.
I'm very supportive of trying that. The data on calorie restriction is very good. The calorie restriction would be reducing your caloric intake to levels that are just above malnutrition. For me, that would be about 1,500 calories a day. The data is very good, but it's almost impossible for people to adopt. Eating that few calories is difficult, and then on top of that, getting the right balance of macronutrients with that few calories is a challenge, and getting all the micronutrients you need. So that probably works, but it's not. It has some side effects, and it's not easy to do. But researchers in mice first found that if you do what's called every other day feeding, you can give the mice everything they want one day and starve them the next. They live as long as the calorie-restricted mice, but they eat as much as the normal mice, because on the days they have food, they eat twice as much almost. And that led to the idea that even in calorie restriction, it might be the periods of not eating that are good for you. And so that's led to things like 5-2 diet, time-restricted feeding. There's a scientist at USC, Walter Longo, has a company, El Nutra, that develops diets that mimic fasting. There are all kinds of different strategies out there. And it looks like that may be a way to get a lot of benefit. If you go for a period of time every day without eating, you're probably pushing your body toward a different kind of metabolism, more toward ketogenesis, which burns lipids and fats. And that's probably a healthier metabolism, at least part of the time. So, I think the data is not fully in on that, but I'm optimistic about that one.
So the other thing I wanted to talk to you about some of these geroprotective drugs, and you mentioned earlier that sometimes, what we do is we just take everything and they may be canceling out. And so I'm interested in hearing that, because I'm taking a lot and probably canceling out the benefit of it. So I started on metformin and resveratrol and NMN and a few other things that I was taking that I've kind of stopped on because I can only swallow so many pills in a day.
Yeah.
Let me ask you, from your perspective, and maybe the top 3 or 4 of those, metformin in the United States is a prescription, so we'll get to that in a second. But what about forms of NR and NAD+? What are your thoughts on that?
Yeah, I mentioned AKG, and I'll compare it to NAD. These are both metabolites that are important for many, many different reactions in your cells, and they go down with aging. And so the idea is that if you restore them orally through a pill, you can improve your cellular metabolism and other aspects of cellular function, and that'll improve health span. I think that is a lot of supportive data with supplementing NAD, which you can do with nicotinamide mononucleotide, which is NMN, or nicotinamide riboside, which is NR. There's a lot of debate about which of those are better. I think maybe that's beyond the scope of today's discussion. But the challenge with both of them is that they are not great at getting converted into NAD, which is the molecule that matters in your body. And so we're still looking for strategies on how to supplement NAD levels better. So I think it's a promising area. I'm a little bit skeptical about the efficacy of these things right now but I think that may be more about oral bioavailability than it is about the benefits of actually restoring NAD, which seem to be there in animal models.
So let's talk about alpha ketoglutarate, Rejuven, which is a product that you've been, involved with.
Yeah.
Tell us how that works, and because, that I have not been familiar with it prior to kind of researching what you were doing, and it's definitely piqued my interest right now as to a way to, maintain a health span.
Well, there was another group that had shown that it extended lifespan in worms, and I apologize, I can't remember the name of the authors on that. It was like a early 20-teens Nature paper in worms. And so this company, PDL, they wanted us to, when I was at the Buck working with Gordon Lithgow, to find combinations of natural products that would have beneficial effects on health span and lifespan. So we tested a lot of things in worms and then validated them in mice. And AKG was the big winner. It really, you can give it relatively late to mice. We would start at 18 months of age and still see it reduce frailty. 18 months is maybe a 60-year-old human. It would still reduce frailty and extend lifespan and improve stem cell function. So we've been looking a lot into this now, and the company developed a product. It turns out that combining it with vitamin A if you're male or vitamin D if you're female improves those benefits. So that's what the product is. But we're really interested mechanistically in what AKG is doing, and that's a challenge. It's also a challenge with NAD because, like I said, they're doing 700 different cellular reactions. Which ones are the most important? And so we've been working really hard to understand that. One of the things we think right now is that AKG is actually restoring a more youthful microbiome in the gut, and that's improving the barrier function of your intestines. So your intestines are very important, not just for what they take in, nutrients and other things, but what they keep out, bacteria and pathogens. And as you get older, you don't do a good job of keeping those bacteria or inflammatory agents that come from them out of their bloodstream, and then so you get higher inflammation and ultimately infections. And it looks like AKG is helping improve that, and that may be why it's working better in older populations, because those people are more prone to declining barrier function. But we found many other things that AKG does as well. I think that's a challenge with all of these interventions right now, is to understand mechanistically what they're really doing to impact aging. As I said, if you just look at all those pillars, they affect all of them, but that's not the direct action. The question is, what is the direct action of the drug? And those are downstream effects. And if we can understand what the direct actions of these interventions are, then we'll do a better job of being able to combine them together, I think. So we're trying really hard to figure out what the targets of all these different molecules are. But for AKG, it's still challenging.
Are you taking AKG?
I am taking Rejuven, yes.
And how do you get Rejuven right now? Can you get it on Amazon? I mean,
You can buy it online. I think it's available on Amazon. I get in trouble for not knowing that, but if you just look up Rejuven and Ponce de Leon Health, it'll show up, and you can figure out where to get it. I think you can get it on Amazon. So.
Metformin. What's your thought about that?
I think it's a promising molecule. The effects in animal models are very small. So if you just looked at that, you might say, I don't know. But the retrospective studies in humans suggest that it's slowing aging. The problem is they're retrospective studies, which are not as good as prospective studies. And so that's why Near Barzilai and colleagues have been trying to get this TAME study supported in the U.S., which is looking at 3,000 people and trying to prevent chronic diseases in people in their 60s. Now, you probably know, or the listeners probably know, that metformin is prescribed for diabetes and hyperglycemia. But the idea, based on these retrospective studies, is it's preventing other diseases of aging simultaneously. So this clinical study they're trying to do is to see if it prevents those other diseases in a prospective way. If it does, I think it's great, because it's a drug with, I mean, no drug is safe. I mean, but it's pretty close. As safety goes, it's really high, and I think that a lot of people already take it. So it's, I think there's a lot of potential there, but we really need those prospective studies.
Resveratrol?
I've been in a lot of fights over resveratrol over the days. we published that resveratrol is not really activating SIRT1, and that led to some interesting discussions with David Sinclair. We're friendly again now, but that was about 15 years ago now. But I don't know. There may be health benefits there. It's again, does a lot of different things in the cell, so it's hard to figure out what it's really doing. I'm not a big believer that it's activating sirtuins, though. So.
Okay. How about spermidine?
Spermidine works in our hands, at least in mice. So it extends lifespan and improves metabolic health and with age. So I think it's promising. Yeah.
Are you comfortable saying what your regimen is right now?
Right. Well, I try to follow this rule of doing one or two things at a time and not doing 10. Because right now I can't mix things together in mice and get additive effects. So I take the rejuven, and I try to have a pretty healthy lifestyle. But I've also tried intermittent rapamycin in the past. I've tried, like I said, I've tried mesenchymal stem cells. So I'm kind of the experiment more than the experimenter these days. Mm-hmm. I'm not sure I'm a good model for what people should do, but I do take the rejuven. Yeah.
As we're coming towards the end of our time, I wanted to kind of get your thoughts on the future. With the exponential speed of computational technology compared to where it was 10, 15, 20 years ago, I have to imagine that the changes or the potential changes are enormous. And the question is, can we focus on them? Do we have access to them? What is the hindrances or the impedance towards progress with significant health span and subsequent longevity?
Well, I think that academic science in the aging field is still poorly funded. That's one big problem. I mean, private sector stepped up, and that's great. I work with companies. I'm happy to do that. I'm very supportive of that. But the beginning of the pipeline is the basic science. It's still the people that are trying to get knowledge for knowledge's sake, and we've forgotten the importance of that. So we might be getting better at translating the things we know, but we're not getting better at finding the things we don't know. And there's still a lot we don't know about aging. So I would, if the NIH is used as a model for funding aging because they've had a National Institute of Aging for many years, which I've been very supportive of and reviewed grants for. But still, the amount of money that goes into aging research is tiny. It's less than 1% of the budget when it's the biggest risk factor for everything. And remodeling that to put more research into aging in the U.S. and in other countries would be extremely valuable, because the private sector is not making those basic discoveries yet. You mentioned data also. I think that the AI I've got more and more people doing dry lab research, AI research in my lab. It's great. But I don't think there are enough people taking the results of the AI and trying to work backwards to understand what that says about the biology of aging. You can spit out a number that says this is your biologic age, but why? What does it mean? What happens if you look at the big data? Can you interpret that in a way that tells you something about aging. And so people like Peter Fedechev, who works at a company called Gero, they're really, I think, doing great stuff because they're trying to work backwards from big data and say, well, what does this mean about why we age? And so I think that that's important. I mean, there's been a lot of private sector money. We can always use more, but I think that, yeah,
Is there
I
enough?
think the momentum's in the right direction, but there's things that still need to be done for sure. Sorry.
Is there enough talent in the field? Are academicians, are they drawing people who are interested in this field now?
It's getting too competitive for me. So if you're like trying to get in the field, don't go. No, I don't think you can ever have enough talent in the field. Yeah, exactly. I don't mind being obsolete. I don't think you can ever have enough people in the field. And the great thing is we're bringing people in from computational science, from physics, from all other areas to look at aging, and from medicine. More clinicians are getting interested. So I think that can only be good in the long run. So more talent is never a bad thing. I think there's only one answer to that question. But what we're seeing is that, I go to aging meetings now, and there are all kinds of people there. They're pension fund managers, and it's good to see it. We used to call it a traveling circus because it would be the same 100 people convening in 4 different places in the world every year, and that was quaint, but it wasn't really getting us very far. I think it's great now that we have all these different people showing up.
What about politics? Do you find that to be an impedance or helpful?
Well, it depends on what you mean by politics. There's politics and academics, which is rarely helpful. And then there's real politics, which is I don't know. I'm trying to. What can I say about the United States? It seems like a failed state. I just feel like that healthcare is one example. It's like we need some people that are in a regulatory position in the government to really focus on the healthcare of the population. And right now we're focused on extracting the money from the healthcare system, it seems like. And I don't know. It's a frustrating world, global geopolitics right now.
So let's talk about your predictions then for the future. I wanted to find if you're an optimist or a pessimist or kind of agnostic on it. Tell me what you think about your field in particular. Where's it going to be a year from now? Where's it going to be 10 years from now? And where's it going to be 50 years from now?
I don't know about a year. I think in 10 years, we'll have validated interventions that slow aging. They may be modest, like I said, but that's a big step forward. If we can promise people 5 extra years of healthspan, that's more than you would get by curing cancer. So, and the economic savings are greater as well. So I think that we'll start to see things like that, certainly by 10 years. 1 year, possible. We have to get more recognition of that too, and get people excited about it, and find governments, speaking of politics, that are willing to support interventions that extend the health span of their population. We can do the economics and tell them how many trillion dollars they're going to save if they keep people healthy, but somebody has to embrace that concept and get behind it. And right now there's still hesitancy. There's your politics. I think in the long term, we're likely to find really more radical changes that have a much bigger impact on maximum life expectancy. I don't know if that's 20 years or not. Maybe it is. And the more we have people thinking about these futuristic concepts, the better. I think that, when I'll use Aubrey de Grey, when he got in the field initially and said negligible senescence, most of the field was like, this is not helpful. We can't even achieve any effect on aging right now. And now you talk about fantastical stuff that nobody's going to believe. But I never felt that way. I think that, I'm more in the let's validate what we can do now part of the field. On the other hand, we need people that are thinking big too, because the rate of technology development is getting faster and faster. So these big ideas might be applicable faster than you think. So I think having people that are thinking what this nail down positive effects short term, along with people thinking, how do we disrupt the whole paradigm in the long run, I think that's the best way the field can go.
With that, we have taken all the time that I think I can get from you, and I can't tell you how much I appreciate you being a part of this podcast. Dr. Brian Kennedy is really one of the world's experts on longevity, and I've certainly learned a lot, and I know our audience has as well, and thank you for being a part of this podcast.
My pleasure, anytime.
All right, look forward to speaking to you sometime in the future. All right, thank you everybody for joining us here on Beauty and the BS, and come back and follow us next time. Goodbye, everybody. The Beauty and the BS podcast executive producer is me, Dr. Peter Grossman. Our producers are Max Banta and John Largent, and editing and post-production services are provided by Game Day Media. You can listen to Beauty and the BS wherever you listen to your favorite podcast. And if you would like to leave a comment or ask me a question, go to beautyandthebspodcast.com and click on the microphone icon, and we may use your comment on a future episode. You can also find our archives, video clips, and more on the website as well. Thanks for listening to Beauty and the BS with Dr. Peter Grossman.